Alright guys, welcome to the first video in the Unit 5 review. We are getting into quadratics. So, if you are watching this and you are in year-long algebra, this is where, I know my kids, this is where we left off, was in quadratics. If you were in semester-long algebra, you probably haven't gotten to this yet. So it's not really a review for you, it's more like new material for you. And then for, again, those of us that were in year long, it's kind of review, kind of new. It's the last thing we were doing, so it may seem like a foreign language again. But hopefully, like, by the end of this, you'll remember a lot of it, and those of you that have never seen it will, like, will know it's not terribly that bad. Okay, so just as a refresher, what a quadratic is a function that has an x squared in it, and that's the that x squared is your highest exponent. So any variation of f of x equals x squared, if you've got a squared in it, it's the quadratic. And when you graph it, it has a parabolic shape or a U shape. So it looks something like this when you graph it. Okay, and so yeah, we'll be messing around with that today. So let's go ahead and get started. So number one, Kathleen has 70 feet of fencing to make a regular pin or rectangular pin for her dog. Complete the table below for rectangles with the given side lengths. Okay, so we're making a pin that is a rectangle. So we have the length and we have the width. And remember, we have 2 of each length and 2 of each width, and that's how you get your perimeter. And your perimeter, when we add these up, should always equal 70. So if I have a length of 5, that means I have a length of 5 on this side and on this side. So that means we've used 10 feet of fence. So if we have 70 feet of fence and we've used 10, that means we have 60 feet left. So I need 60 feet for this side and 60 feet to make this side and this side. Well, half of 60 is 30. So we have 30 feet, 30 feet, 5 feet, 5 feet. So 30 and 30 is 60, 5 and 5 is 10, 60 and 10 is 70. Okay, then it also asks for the area. And to get area, you multiply length times width. So 5 times 30 is going to equal 150. Alright, and then we'll just continue down the same pattern. So if I have a length of 10, well, we have 10 and 10 is 20, which leaves me with 50 feet, and half of 50 is 25, so 25, 25, 10, 10, 25 and 25 is 50, plus 10 is 60, plus 10 is 70, so 10 and 25. And if I multiply those, 10 times 25 is 250. So something else to remember, you know, we said we have 2 of every side length, right? So we have 2 lengths and 2 widths. So the length and the width should add up to the same thing as this length and this width, right? So I could have length and width equal 35 plus 35 equals 70. So my length and width together should always equal 35. And if I add 5 plus 30, I get 35. 10 plus 25 gives me 35. So instead of trying to figure out, oh, I've got double of this and I got to make it equal 75 or 70, let's just make it equal 35. So plus 20, 15 and 20 will give me 35, and then 15 times 20, let's see, 10 times 20 is 200, 5 times 10, so that should be 300. Okay, should have 20 and 15 here, and that would give me 250. And then we should also have 25, 25 and 10, and that should give me, this should give me 300, this should give me 250, 150, and then here we've got length times my width, or length and width together. So what it's looking for, I'm not actually sure what it's looking for. I'm not sure if it's looking for W or if it's looking for 35 minus L. Because if we take 35 and minus our length, we get our width. But I'm not sure what it's actually looking for right there. And then my area would be either length times width, or we could say length times 35 minus L. Which I think that's what that's looking for, but it really wasn't very clear. So let's just go with that. Okay. So yeah, to get our width, you would do 35 minus the length. So we're going to go with that because that's going to end up giving us a quadratic. I think that's the route we're wanting to go. Alright, so B, let X represent the length of the pen. So X is our length, Y is our area. Alright, and so we want to make sure that we've graphed this nice and neat. So we're going to go by fives. Let's see, 10, 15, 20. Okay. So that'll work. We'll do this. We'll skip 2 and go by 5. So we've got 5, 10, 15, 20, 25, 30, 35, 40, 45, even though we don't go quite that far, but that labels it nice and neatly. So that's our length, and Y is our area, and we go up to 300, so that could be 100, 150, 200, 250, 300. Okay, so we'll go up by 50s here. Okay, that looks a little better. Okay, and then we're going to graph our length and our area. So when my length of my pen is 5, the area is 150. When the length is 10, the area is 250. When my length is 15, my area is 300. At 20, it's also 300. At 25, it's at 250. At 30, we're back at 150. Oop, right here. Not that one. Okay. Alrighty. Is that all we needed to do? Yes. Okay. So if you notice, this is not a linear function like we've been working with. It's not an exponential function that we worked with. This has that parabolic U shape. And so what happens is as you increase the length, the area increases until you get to somewhere between 15 and 20. Because after that, the area starts decreasing again. Because your width is going to be decreasing. So we have to get our pen into a shape that's going to give us the most area possible. Alright. So C asks us to write a function, a of x, that gives us the area in terms of its length. So normally we do length times width. Well, to get our width, let's go back to here. To get our width, we take 35 and subtract the length. So we have length times 35 minus the length. Okay, well let's clean this up a little bit. Let's distribute my L. And what we're going to have is A of X equals 35L minus L squared. And it asks to write this in standard form. Now what standard form looks like, I'm going to do this in a different color up here. Standard form looks like AX squared plus BX plus C. So if I want to take this and write this in standard form, we'll take the squared term and put it first. Take our, and then we would take our term that's got an exponent of 1, or I guess you could call it our linear term. If you remember from polynomials, this would be our quadratic term, our linear term, and then we would put our constant at the end, but in this case we don't have a constant. So this would be in standard form because we go from the highest exponent down to the lowest exponent. If I want my A value, it would be in front of the L squared, which is the negative term. And since it's just a negative sign, we're going to go with -1. And our B is what's in front of the L without the exponent. So that's 35. And then our C term is, we don't have one. So that would be like me putting +0 at the end. It doesn't really change anything. So we'll say our constant is 0. And there we go. We turn this data into a quadratic function. Okay. Okay, so that is standard form. So part 2. We have this quadratic function, and it wants it in factored form. So factored form, what we're going to do is we're going to take this trinomial and factor it. So we need two things that multiply to give me -3, but when I add them, I get -2. So we should have f of x equals, we know we're going to have two binomials since we're factoring. Since we have x squared, we're going to have x and x in the front. Okay, so this is negative, which means one of my terms is going to be positive, one of them is going to be negative. This tells me that the larger term is negative. Okay, so let's think of things that multiply to give me 3. And the only thing I can think of is 1 times 3. Okay, if I do 1 minus 3, I get -2. So we're going to make 1 positive and 3 negative. And this is my quadratic in factored form. Okay, so factored form, if you want a little, kind of like I did with standard form up here, factored form, what that ends up looking like, it looks like x minus p times x minus q. You have x, and you have two x's, and then your two factors. And what's neat is p and q are the x-intercepts. So yeah, this is called factored form, but it's also called intercept form. Okay, so it says to find the x-intercepts of f of x, use the factored form f of x and solve the equation f of x equals 0. So we're going to take this and put 0 where f of x is. So we have x plus 1 times x minus 3. And if you have two things and you're multiplying them and you end up with 0, so you have something times something equals 0. So you have something times something equals 0. Well, the only way to get 0 when you multiply is either this blank is 0 or this blank is 0, or they're both 0. So I need to make sure that x plus 1 equals 0, or x minus 3 equals 0. So what can x be that would make one of these factors equal 0? So you could solve these equations. You could subtract 1 from each side, and you would get x equals -1. You could add 3 to each side and get x equals +3. And when you go to graph it, you should have x-intercepts at -1, 0 and at 3, 0. Okay, so then we get we're looking for the vertex of the quadratic function. So the vertex, like if we look up here, the vertex would be somewhere on this line because it's the middle of the function, and it would be the highest point of that function. So if I were to connect my dots, this right here would be my vertex, that highest point on my graph. So I don't have a way to, this isn't graphed, so I can't find the vertex yet. But what I can do is there are some formulas for the vertex. So what we could do, the vertex formula is -b over 2a. And this will give me the x-coordinate of my vertex. So if I look at my equation, I'm going to just plug in my b and a values. So I have -b, well, b is -2 over 2 times a, and a is just 1. There's nothing there, so it's just 1. So I have -2, which is +2. I have 2 times 1, which is 2. And 2 divided by 2 is 1. So that's not the vertex. That's just the x-coordinate of my vertex. Every x needs a y. So to get my y, I'm going to go back to my function and plug 1 in for x and solve for y. So f of 1 equals 1 squared minus 2 times 1 minus 3. 1 squared is 1. -2 times 1 is -2, minus 3. 1 minus 2 is -1, and -1 minus 3 is -4. So my vertex is, I use the x that I plugged in, so 1, and I take that y value I just got, -4. So my vertex of this equation should be 1, -4. Let's see, I do have Desmos on my phone, so I can graph that real quick and show it. Just gotta find my Desmos app. Okay, so let me see if I can, there we go. Got the exposure down a little bit, that should help. Okay, so in my equation was x squared minus 2x minus 3. Okay, so that is my quadratic that is graphed. So we're just going to double check. So my y-intercepts should be at -1 and 3. So let me click on those real quick. We have -1, 0. And we have 3, 0, so we did good. And I don't know, it's kind of hard to see I don't think there's a really good way to do that. You can kind of see it. And then my vertex, that bottom point, is at, can't really see it. There we go, -1, 4. I'm sorry, 1, -4. I can't read. That's why I teach math. So if you need to see all the points, I think that's the best. Try not to get a glare. But we have 2 intercepts and a vertex. Okay. And let's turn the exposure back up. Here we go. Alright, so number 3. We want to complete this table of values and then identify the minimum and maximum of the function. So just so you know, you will never have both a minimum and a maximum. You will only ever have one or the other because it's a U shape. It's not a squiggly that has multiple of these. It's a U. So it'll either have a bottom, or if it's an upside down U, it'll have a top. So it's going to have a minimum or maximum, never both. Alright, so we have this table of this equation. We have a table of values. So what we're going to do is we are just going to take these and plug them in for x, which seems a little tedious, but it is what it is. So I normally like to have a middle column in this table for me to do my work, but that's okay. We're just going to do some work to the side. So we're going to do -3 squared plus 4 times -3 minus 1. Quick calculator info. If you plug in -3 squared without parentheses, you will get a negative number here, and you should get a positive number because a negative times a negative gives you a positive. So if you're using a graphing calculator, make sure that you are using parentheses when you square something. Else it'll do 3 squared and then make it negative, which is because it's following the order of operations. So you need those parentheses to make it very, very clear that you're squaring -3 and not squaring 3 and then making it negative. Okay, so -3 squared is 9. 4 times -3 is -12. Minus 1. 9 minus 12 is -3. Minus 1 is -4. So we have a point at -3, -4. Okay, let's plug in -2. Okay, -2 squared is 4. 4 times -2 is -8, and then minus 1. 4 minus 8 is -4. -4 minus 1 is -5. Okay, plug in -1. Okay, -1 squared is positive 1. 4 times -1 is -4. So 1 minus 4 is -3. -3 minus 1 is -4. Okay, 0. 0 is the easiest because 0 squared is 0. 4 times 0 is 0. So everything will cancel except for that last term, which is -1. And then let's plug 1 in. We'll do it over here. So we have 1 squared plus 4 times 1 minus 1. So 1 squared is 1. 4 times 1 is 4. And we have minus 1. Well, 1 plus 4 is 5. 5 minus 1 is 4. So this should be 4 right here. Okay, so then we need to figure out, does it have a minimum or a maximum? And what is that min or max? So let's kind of think about this. These points are going from left to right. At -3, we're at -4. At -2, we're at -5. And then at -1, we're at -4. At 0, we're at -1. And at 1, we're at -4. So this is kind of, even though I don't have a graph, I know that this decreases. I subtracted 1. And then here I added 1. Added 3. And added 5. So I went from decreasing to increasing. So that means I should have a minimum, and this should be the lowest point on my graph. So I have a minimum of -5. Okay, so that is the guided practice for activity 29. Please email your teachers if you have any questions. I hope you're all staying safe and healthy and washing your hands and not coughing on each other. And so yeah, so hope you guys have a good evening, and I'll have another video soon. Bye.